So this is what I get up to when I wake up in the morning. Start the wallet. Turn on the server. So you see 3 copies of a server. You know, the server torrent. Open. No, I don't want to open that. I want to mount that. Multipass. Mount that disk image. Come on, server. Open. Boom. Everything that was up top is now down the bottom. It was sitting up here in downloads. Then I mounted the file and it moved down here to disk drive D, right next to the network. What I wanted to do was get a DeepMind component inside my server. I've got a few of them over here. I've got some Cloud DeepMind and some BCI programs. So we'll check out the BCI programs. Here's a model that I use quite commonly. BindsNet. That's a government spec development. BindsNet. It's available on open source. It's pretty. Open the PDF. Open that. Welcome to the BindsNet documentation. I've read this a few times. Just doing this for the video. BindsNet takes TensorFlow, spiking neural networks, 3rd generation of neural networks. Neurons are connected with directed edges, which are general plastic synapses, may have their own dynamics as well. And over here, see it says the development of BindsNet is supported by the Defense Advanced Research Project Agency grant. And it's actually got the grant number. You can Google this grant number of the BindsNet grant and find out exactly who funded it. It's quite interesting. Spiking of neural networks and government funding. Sometimes I run BindsNet. I find it mildly detrimental to the nucleus, but it's alright. If you're in a safe environment and you want to guarantee it's safe, you turn on BindsNet. Some Kubernetes. What else? Here's a neural plasticity model that I use quite often. It's called Neuron. And then you click on Neuron Demo. And basically it puts out a 3D linear grid and connects to your membrane synapses. See it says there, loading membrane mechanisms. And there's all the membrane mechanisms for functionality. It's got an invalid escape sequence. Other than that, it works. It's got a unique set of membrane mechanisms. That's what I like about Neuron. I don't profess to be a neuroscientist, but I work with creative AI and AI technologies. And I do quite enjoy this. Room control, more spiking details. I like to put that on. Clamp, synchronizing artificial shells. Synchronizing the artificial cells. If you put one above and one below, then it spikes between a high point and a low point. You can actually change the Celsius and degrees of your brainstem. It recommends you turn it to 16.3, but I find if it's a little bit cold, change the modularity up to about 17. Try not to cook your brain when you're doing this. I don't advise kids play with neuroscience. It's an actual real thing. It's not like some make-believe myth. It's an online BCI download, a brain-computer interface. You can see the errors in my files. That's just my storage saying I've got too much storage, too much stored. These are all BCI programs, brain-computer interfaces, every single one of them. Except for that one there, which is a 4D LUT, which I'm not going to tell you what I use that for. This here's another neural interface I use, which plots a linear grid. Basically, to explain it more easily, it interfaces with the ports, so it comes straight from here, and it folds out this algebraic equation, which ends up being a triangle, and then it folds out again sideways, so it's like psh, psh, psh. And it's called a cluster. And that's a cluster. And you set up the cluster to learn. You plot it to learn, and that's set in a wave. And depending on what the maximum weights say, you adjust it. Sometimes I like to use a different network structure. I like to use a 10 by 10 2 by 10 by 10 by 2. It's more complex. I find my brain works really well on the 2 by 10 by 10 by 2. I mean, everyone's different, but I find it quite functional to have a lot of choices rather than a minimalized choice. I mean, if you're rolling it out for somebody else, you basically change their choices into like a 2 by 2 by 2, which means like if they say no and I say yes, then it means no, it means yes. It's a pretty simple way to put it, but pretty much. But for myself, I put it on a 10 by 10 by 2. And then I put it on train, and it trains on a linear grid, a wave. As you can see down here, there is spiking going on. There's neural spiking going on in the background. See how it's spiking, and see how it found it hard to make the wave. Usually it makes the wave smooth, but it didn't. And on the edge here, you can see the outside interactions. 1 point there, and 1 point there, and 1 point there. And these 2 points here are actually a linear interaction that's joined together, which is hindering my neural network or linear tensity setting up. It's actually right across here. So this shape here, it's another triangle. See that? It's an outside. There's an outside neural network. But yeah, that's what I get up to in the mornings. Set up my server, turn on the crypto torrent, and then plot the neural grid. Sometimes I like to plot over these. So you just change it. So you can see all the individual ones that just plot over them. You can see the interactions, just plot over them. Just strengthen the edge of the wave. Later. As you can see, where I dot, it dots over it. And then you go to train it again. It should come up better. It's still set to a wave function. See as it runs the epochs? It's at a 12% fail rate. It's coming down. See, it's coming up. Well, it's coming up, but there's a linear pressure on it. It's floating off. Almost got it. That's better. See, just plotting over those interactions brings my neural network up stronger. And my fail rate comes down to 3 point, oh, there we go, 0.98%, 1% fail rate on my neural network. Thanks for watching.